Thank you very much, Anita. Dear friends, we are gathered here in Hangzhou by a common interest in and love of the colors offered by nature. I view this symposium, Colorful World, Natural Dyes, as a contribution to continuing the transmission of our global heritage of colors. For the transmission of knowledge on the art and science of natural dyes and its promotion, international symposiums such as this first Biennale on natural dyes are essential, and they have played a major role in the past 30 years. They provide occasions both to report on advances in our awareness of the major importance of color and its production in ancient and traditional human cultures, and to learn and reflect about present developments and issues concerning natural colorants. Archaeological research and archaeometry have been revealing how unfathomably ancient and elaborate humankind's quest for color and knowledge on the art of dyeing are, and how central to cultural identity they have always been in all parts of the world. We are going to learn more about this during the first session of the symposium. How do we know with what colorants these ancient colors were obtained? Thanks to the considerable advances in dye analysis that have been made in the last 30 years, particularly high-performance liquid chromatography, HPLC, that allows to separate and identify all the different components of a dye, resulting in a unique fingerprint for each sample of ancient dye. But another question, which is going to be examined in the second session of the symposium, is how can we know how, by what technical processes, these beautiful ancient colors were obtained? There are two ways of getting such technical information. The first is in the rare instances where there is an unbroken oral and practical transmission of traditional dyeing. The other way is to study historical written sources on dyeing techniques. All over the world, there still exist two rare examples of unbroken transmission of traditional technical knowledge. This is often due to the symbolic and medicinal powers attributed to many dye plants. In the Chinese, Korean, and Japanese cultures, the survival of dyeing traditions is connected with beliefs in the connection between the powers of the dye plants and the colors they produce. We are going to hear more about that too. The art of Basilan and Bogolan in West Africa is also based on similar traditional knowledge on the medicinal powers of the dye plants. Ethnobotanical and ethnopharmacological research have shown that still today, in different parts of the world, cultural identities are narrowly connected with the use of some particular dye plants and also the mastering of associated dyeing techniques. In Europe, too, some rare and therefore precious dyes, such as insect reds, were also attributed symbolic and medicinal powers. But in Mediterranean and European civilizations, dyeing techniques were early documented by written documents, some of which give very precise recipes that have been shown by the development of experimental archaeology to give very beautiful and fast dyes. Moreover, archaeology of urban sites in Europe, in various parts, different countries, has shown that the majority of people didn't go with undyed textiles or brown or grayish clothes, but that they were wearing dyed, colorful clothing. With the development of textile industries in Europe, dyeing had to be done at massive industrial scale. Since end of medieval ages, 18th century, the size of the dyeing vats and the length of materials that was dyed in a single batch were actually larger than what is practiced today. And of course, it required standardized and reproducible procedures. Dye sources and dyeing techniques were described in dyers' books that represent really precious sources of information. Let us consider the example of dyeing of broadcloth, wool broadcloth, in the south of France in the 18th century. It is very telling because it shows, first of all, that a small range of colorants had already been selected for both fastness and availability. They were sourced both locally and internationally through a very important international trade. And also the selected sources were both cultivated and collected in different natural environments. For instance, about yellows, weld, the dye on the left, the plant on the left, was cultivated at rather big scale, whereas young fustic, you see in the middle, and the plant, the Mediterranean plant on the back right, on the bottom right, were collected in the wild, but on a really big scale. In the industrialized societies of Western Europe, intensive chemical research and investment, economic investment into dye sources and dyeing resulted in the discovery and massive adoption of synthetic dyes, leading to the demise of natural dyes and associated dyeing techniques, and resulting in a total disengagement from research and investment into natural dyes. But today, the state of the earth obliges us to face urgent challenges for our children's future. Every day we get more information on threats on natural environments worldwide. Everybody is aware of the accelerated exhaustion of fossil resources. Natural colorants can contribute to the development of a new, sustainable green economy and regain a larger place in our societies. This is what will be examined and discussed in the third and last session of this symposium. Dye plants and animals can be renewable resources, but only in certain conditions. The first condition needed is intellectual. We need a complete paradigm shift in everybody's minds. It's very difficult for us, surrounded by all these comparatively simple synthetic dyes, to understand, to study much more, and to learn to use and take advantage of the amazing complexity of natural colorants. I give you some examples. Of course, madder reds, which are composed of maybe 17 different major and minor colorants, versus synthetic alizarin, which was the product of the fantastic human genius for chemistry and rationalizing and simplifying things. Another good example is plant-sourced indigos versus synthetic indigo. You can see how more complex the natural indigos are compared with synthetic, and also that they can be distinguished, which is something we'll go back to later. The example of yellow dye plants, at least for the European selected ones, shows that there was always a kind of empiric understanding of the chemical composition of plants, which led to the selection among the thousands of plants which can dye yellow. They selected a few that were mostly containing the fastest classes of yellow colorants. To allow a more significant comeback of natural dyes in our societies and in our daily life, some progresses are still needed. We are going to hear much more about these issues in the third session of the symposium. I have not enough time to address all of them now and to show you all the interesting examples of what is happening in the world in this fascinating field. For now, I'm just trying to give you food for thought and for further discussion. We first examine the development of the necessity of a development of the cultivation of the major historical dye plants, preferably in sustainable organic farming. And let's take the example of indigo plants. On this slide, I try to collect, and it's not so easy, funnily enough. We are in a time of seemingly very easily obtain information, but when you are asking for difficult questions or touchy questions, you don't get the answers you expect so easily. So I try to collect information about the yields and the quantities and the prices I mentioned on this slide are the prices for European customers who want to dye, either artists or craftspeople or industrial people. That's how much we must pay for a natural indigo. And the latest and the most striking example is the action of Henri Joseph in the French West Indies, in Guadeloupe, who has been reviving the cultivation of indigo in the French West Indies, which has a very tragic link with slavery and human slave trade, which is very heartbreaking for us. And so Henri is reviving this indigo with a very paradoxical result. He's producing a very, very good, very pure indigo, but it's so expensive that he can hardly sell it. Another example is, the issues I identified from this inquiry is probably there is a major superior demand nowadays for natural sourced indigo than the actual present production. So there is room for development of good quality, pure, authentic, natural indigo, and preferably at accessible prices. The lack of, probably this lack of natural indigo has encouraged some degree of falsification. So that's a very big problem for all natural colorants, mixtures with cheaper sources or with completely or with synthetic colorants. What is striking at the moment is both the revival everywhere in the world of the traditional sources of indigo. There is everybody in their own country are trying to revive the cultivation of their traditional indigo sources, which explains also the very widely diverse yields and qualities. In Europe, wood was not such a good source of indigo, but we had nothing else. So that was developed in massive scale. Now that the world is just one big bowl, people can compare and choose their sources of indigo. The result also for all colorants, I must say, is a need, a cruel need that is being evoked at every international symposium for the last 20 years, the need of certifications of traceability, of also easy, quick and cheap analytical test kits. Because at some point people will want to know what they are paying for and if it's really worth it. About red dye plants and yellow dye plants, I think the example which naturally comes to mind when you are a European person is Madder, Rubia tinctorum, and Weld, which were the two red sources and yellow dye source, which were most cultivated at a biggest scale. So you will also have data on this present cultivation, and you will hear more about it because the person who has started the industrial comeback of these plants is here in this room and will be talking tomorrow morning. The issues I can see in the sourcing of red and yellow dye plants are as follows. Madders. There's a big problem about madders, like for natural indigo, because they are at the moment sold without big care of mentioning exactly where they come from and from what plant, what species. And the botanical species is not a kind of hobby for botanists. It's very important because it implies a particular chemical content. So if you are selling Rubia tinctorum, the roots, you won't get the same dye effect, you won't get the same colors, and not as easily or in the same way as if you are selling Rubia cordifolia from India, for instance. But when you get madder, very often at commercial scale, you are not told what species it comes from. There's also an urgent need to cultivate madders, all madders, because what you use is the roots. And when you uproot a plant in its wild environment, you make sure that it's not going to grow again. And that's what's happening in the world everywhere at the moment, except in the places where they are cultivated, preferably in organic farming. So we need to cultivate and commercialize more diverse sources of fast yellow dyes too, because there's such a wealth of possibilities. And even from an agronomic point of view, it's an interesting challenge, and there are very good yellow dye sources for every type of geological environment and for every type of climate. And in this matter, the study of historical documents is very useful too, because you can spot sources of yellow dyes that were preferably used in some, for instance, in my experience, European countries that are not growing them any longer. So there are lots of possibilities. Also, exploring new dye sources. What I call new dye sources would be, in some cases, growing at bigger scale and commercializing at bigger scales plants which have already been used, which are traditional in some among some people and in some parts of the world, but which have remained very local, and their dyeing techniques also very local. For indigo in Southeast Asia, I would suggest Marsdenia tinctoria, a plant that I met both in Taiwan and in the south of Japan, which is quite important for some mountain people in Vietnam, where all these beautiful photos come from the research of Dr. Ngoc and Lu Dam. And this Marsdenia tinctoria is important because it's narrowly associated with the very heart of some cultures, like the Karbis of Assam in the northeast of India, or to the Iban Dayak of Borneo in Indonesia. New dye sources are also waiting for cultivation, identification, cultivation, and commercialization. In many countries, I have had the pleasure and honor to be involved in some PhD thesis on the potential, the color and potential of different countries like New Caledonia, with this student who has now started a company to exploit the coloring value, very important potentials of totally unknown Caledonian plants so far. And another action which has been inspired and is still guided and inspired by André Eteve, who is with us today and who will be talking later, is a PhD thesis in progress by Mairi Andriamanantena on the promising sources of natural dyes in Madagascar, with a high proportion of endemic plants you couldn't find anywhere else in the world, which have been known for their dyeing properties, but new ones are being discovered. I will give you only a few, very few examples, and André will give you more tomorrow. No, this afternoon. This plant, which has the originality of being able to dye green in a single bath, which is quite rare in the world, and it gives a beautiful and fast green. And this Arungana madagascariensis, which wears the name of its country of origin, with the beautiful colors, orangey colors it gives. Other possibilities which should be developed if the use of natural colorants is going to be more massive is all the massive industrial waste, the natural waste of industrial uses of plants. I'll give you the example of a factory which is very close to my home village. You all know that in the south of France we grow a lot of grapes for wine and for grape juice. And nobody thinks of the massive mountains of waste this cultivation develops. You know, you have all the branches of the grapes, all the skins of the grapes once the wine has been pressed. And what do you do with them? They just sit there, attracting flies and stinking and polluting the environment, when you can, as here, use this to obtain very good purple colorants, which are unfortunately not fast for textile dyeing. So that's another breakthrough, and a chemical, technological breakthrough to make these colorants, which are already vastly used in the food industry, to be used in the textile industry too. Other massive wastes which could be sources of colorants are all the terrible waste of timber, cutting, precious woods. When you fall down, when you fell a tree, you have to dig a huge trench in the forest. All the vegetation in the trench is wasted. Then when you arrive at the tree, you cut it down, forget about having it again in our time, but you also leave on the spot the roots, the bark, the leaves, the branches, the twigs, and all this is full of tannins and colorants. At the moment, it's just letting to rot. I gave the example of teak. In the case of teak, you imagine the amount of plantations. André Eteve, among other people, has shown that the leaves, even when they fall down in the season when they fall down, are a rich source of red colorants, red and orange colorants. All this could be used. And again, barwood, which is a precious dye wood, but also, unfortunately, a very good sculpture wood. I brought this because the Philippines, which are not a country which is not represented here, has a department of the Ministry of Agriculture to do research into potential sources of new colorants. And they discovered this wonderful range of pinkish brown colorants from the outside skin of the coconut, which is being grown at massive scale both as a fruit and as a source of oil. So unexpected sources of colorants are still to be discovered. Another field where progress can be made is in the energy used to extract and produce these natural colorants. I here give the example of a very far-sighted action Michel Garcia in Loris in Provence had encouraging the production of a prototype of a solar heater to extract indigo from indigo plants. And you will hear more about soluble colorant extracts, both from Anne de la Sayette and from Cathy Hattori, because they are a way to use natural colorants in the same way as synthetic dyes, in the same type of equipment and at the same scale. Another field where we must be active if we wish natural colorants to come back into our daily life is teaching about using natural colorants, and also, maybe even more so, popularizing them, making them known, and also wanted by the large public. There are several ways. Trends at the moment are helped because they have a very positive attitude to natural colorants. I give you the example of Lee Edelkort's trend meetings, which happen twice a year. Natural colorants are also being taught again at professional scale. I give you the example of a project of starting a training center both for synthetic and natural colorants in the center of France, a place which was very famous for its tapestry production. And here, the example of an academic university department which is teaching design in color from the point of view of natural colors and natural colorants in Toulouse. A very important action was Yoshiko Wada's initiative to develop a series of films where the very famous dyer Michel Garcia teaches his know-how, and which these films are subtitled in many languages, making Michel's knowledge available to very widely in the world. That's a very pedagogical action. Talking about pedagogy, natural colorants are increasingly being included into pedagogical programs, such as this, which was co-organized by Jenny Balfour-Paul in the USA to make black children aware of their past and of the connection between indigo production in the States and this terrible slave trade, where the black populations were deported, transported to Americas. There's a school in New Caledonia, a professional college, where they train students in chemistry and also technically from the point of view of natural colorants and their contents. And also a college in France which is training students to become designers of stage costumes, with the results of several shows, in opera shows or theater shows in France, which have been produced with only naturally dyed costumes. And the training was done by Sandrine Rosier, you see, on the top left, who is teaching the director of the costume department at the Opéra Comique in Paris. Myself, I'm trying to help in my way of an historian by reviving the ancient colors for today's designers, by providing them with examples from ancient dyers' books with samples, which also contain recipes and the corresponding colorimetric data. I am planning to publish this type of very practical dye book where you can have the name of the color, the photo of the nuance or color, the colorimetric characteristic expressed in the international system of the CIELAB, which is understood by all industrial people and designers working with colors. So it's a kind of international language. And we have been trying to revive these ancient colors to see if it was not only data which are interesting, but if it really works. And we set up this international team where I was just providing the ancient document and the data contained in it, but a Japanese friend and a French dyer from the south of France, Aboubakar Fofana, who will be with us soon, and Charlotte Cohn and Tim McLaughlin from Canada, all worked with different botanical sources of indigo in different vat processes, and independently try to reproduce exactly, with the exact colorimetric data, the scale of blues provided by this ancient 18th century dyer from the south of France. And the scale of blues, which existed among all indigo dyers in the world since prehistoric times, it's very important not only for the range of blues, but also from all the range of compound colors, the greens, the purples, the grays, many browns, and the best and fastest blacks. So it's very important. It's a basic of natural dyeing. And I just gave the example here of Aboubakar Fofana's results because they are striking. They are exactly comparable to this ancient dyer who was working with wood and indigo vats, and Aboubakar was working with the West African creeper, the liane indigo, the Yoruba indigo plant, and all of the other parts of the team all managed to reproduce this scale of blues by, they were very good dyers anyway, but by adjusting their different vats, they were able to reproduce this scale of blue on the left with color differences which were inferior to 2. And 2 it's an arbitrary measurement, but this measure is what the limit of acceptance by industrial people. Under 2, a batch is accepted. Above 2, it's too different. But it means that these colors are reproducible. So my conclusion is natural colorants and associated knowledge all over the world are our global heritage of colors. They are a treasure, and they are an inspiration for the future. Thank you for your attention.